Hi, this is Alex from devstories.eu. Matplotlib, episode 4 of 5. You have 10,000 data points. You throw them onto a scatter plot, and you end up with a giant, unreadable ink blob where the overlapping points hide the actual pattern. You chose a pairwise tool for a density problem. Getting past the default line chart requires knowing how to match your data's shape to the right visual tool, which is exactly what we cover in Beyond the Line, Exploring Core Plot Types. Matplotlib organizes its core plots into broad categories based on the structure of your data. The three foundational categories are pairwise data, statistical distributions, and gridded data. The most basic shape is pairwise. You have an array of x values and a matching array of y values. You use the plot function when these points have a logical sequence, like a time series, where drawing a continuous line between them shows a trend. If the points are independent observations, you use the scatter function to place individual markers, but scatter plots break down when you have high density. That brings us to the second category, which handles statistical distributions. Here is the key insight. When you have 10,000 overlapping points, you do not actually care about the exact coordinate of point number 4,000. You care about where the points cluster. This is where a function like hexbin steps in. It takes the same x and y arrays as a scatter plot, but groups the geometric area into hexagonal bins, coloring them based on point density to reveal the hidden pattern. Now consider a single array containing the raw ages of all your customers. Plotting them one by one as dots gives you useless noise. Instead, you feed that single flat list into the hist function. A histogram automatically groups the individual ages into ranges and shows you the volume of customers in their 20s compared to their 50s. If you need to compare those age distributions across 5 different store locations side by side, you switch to a box plot. The box plot summarizes the ranges, medians, and outliers cleanly. If you need more detail than a box plot provides, a violin plot draws the full curved shape of the density profile for each store. The third major category is gridded data. This applies when your data is a two-dimensional matrix and you need to visualize a continuous value across an area. Think of a two-dimensional temperature map across a geographical grid. Every position has an x-coordinate, a y-coordinate, and a temperature value. You don't want lines or scattered points to represent this. You want a solid, colored surface. Matplotlib provides imshow and pcolormesh for this purpose. You use imshow when your data sits on a perfectly regular grid, like the pixels of a digital photograph. It assumes equal spacing between every data point and renders very quickly. If your grid coordinates are irregular, perhaps your measurement boundaries warp or compress near certain geographical features, you use pcolormesh. It calculates and draws individual quadrilaterals for every single cell, conforming exactly to the distorted shape of your coordinate arrays. When deciding which Matplotlib function to call, ignore what you want the final picture to look like and look strictly at the mathematical shape of your input arrays. Are they sequential pairs, flat lists, or two-dimensional matrices? That's all for this one. Thanks for listening, and keep building.